Okay, hello everyone. Today I'll show you how to create your own NFT collection, and I'll show you how to do it from scratch. So I have this code on my GitHub. It's public. Please feel free to go clone it, go view it. I'll start in the collection folder. Imagine you've created this collection folder on disk. So on your local hard drive, you just created a folder called collections. And inside there you have images. Now these images are the images of the NFT collection. So these ones are just pulled from the internet. They're just public images, but you can imagine you had a script or something that could create these avatars based on some inputs you gave it. Like if you have to create 10,000, right, elements, you have something like, are they wearing a hat? Are they not wearing a hat? And your rendering software that creates the avatar of the picture can then put a hat on or not, right? So that's kind of what you need to create like 10,000. In this case, I just have 10. And they're basically just cats. That's number 0, that's number 1, and so on. And that's where it starts. So you have your images. Next, what you need is a metadata folder. Okay. The metadata folder is a list of JSON files, and they are named after the images. That's easiest. So like 0 refers to cat number 0 and 1 to cat number 1. When you click it, you see it's a JSON file, and you see that the image being pointed to is some weird string here, /0. Okay, fine. And then there's some attributes. Let me just first explain why we have this file. So this file is what OpenSea will be able to process to display your NFT collection. So you want this file because it's basically telling OpenSea, hey, by the way, this is the name of this particular NFT, particular being this /0. I'll explain what this weird string is in a second. And it has some attributes here, like sunglasses and yada, yada. And I'm putting it in this format because that is what they're telling me to do. So I go over here to OpenSea, the docs, and it basically tells me, oh, by the way, if you're creating an NFT, you want this metadata. Okay, so it's telling me this. It's saying, and I'm going to be pointing here, it's saying you need to create a Solidity file from an ERC 721 contract. I'll show you in a second how we did that. You need to tell me who is the owner of that token ID, and that's something that comes for free, basically, in that contract. And also, you need, crucially, to tell me the token URI. Okay, so that's what needs to point to the metadata. You see how they're saying this token URI needs to point to this metadata. So that's whatever you make that token URI return in your Solidity file needs to point to this file, this metadata file. So I'll show you how to do that. But you can see in the metadata has certain names, descriptions, traits, and so on. Some of these names have changed. These keys have changed, so it's going to be a little confusing. But the idea is still you have this metadata. Fine. So then OpenSea can parse the metadata and show it in a nice way, just like you're seeing here. It can take, for example, the stamina thing, and it can show you in a nice bar over here. Okay, so they're basically taking this JSON and displaying it nicely for you. Okay, what are some attributes you can include? Here's some examples. Here's some examples of, you can even do like a boost percentage. You see this right here? Boost percentage, which will go up here and become this kind of circle here. That's kind of cool. And you have a number, generation number that goes here. Okay, so you can create all these attributes and put them nicely there. You can even put dates as well, like birthday, for example, of the cat, in my case, in my board cats collection. Okay, so that's the point. This is just to interact with OpenSea better. So that's why we have this file and these files, okay? So anyway, you have these two folders now on your local computer, images and metadata. Notice that you actually need images first, and what you need to do is to upload this to wherever you want to host it. Now, it's recommended to host it on a decentralized service, because, for example, if you host it on S3 or someone's personal computer, like a server, and it goes down, you'll lose the images part of the NFT, okay? Now, the NFT is not just the image, right? It's also like the ownership of that particular pointer and so on. It's a more complicated thing. But in any case, you want it to be more decentralized. So one way to do that is to use IPFS. So what you want to do, for example, there's this service called Pinata. Now, this is actually a centralized hosting of the files, but that is just to speed it up because IPFS can be a little slow during the indexing as like the file gets distributed to people in the network. But anyway, long story short is just you want to take that images folder and you want to upload it here. You see how I can upload a folder? You want to do that. Once you've done that, and I did that a while ago here, you see this VYZ, that's kind of the link to that. You upload it here, and that's it. This is the CID. So this is essentially the hash of the content of that folder. It's a little bit more complicated because the CID includes things like what hashing algorithm was used, what IPFS version was used, and all this kind of stuff. So it's a little bit more complicated, but think about it like that. So this is the folder hash. So the link to find this folder is IPFS / this CID. That's the folder. And then you can say /0.jpg or just /0 if your image is called just 0. And that'll give you the image. Okay, that's it. Do that first. Make sure you don't have any hidden files in the folder. So for example, on a Mac, you want to do ls space -a to make sure you don't have any hidden files, because sometimes it puts this ds store file in there. You don't want to also upload that. Make sure you don't have that. Now, once you've uploaded here, and it's very easy again, you just do the folder. You, by the way, also double check with IPFS Desktop. There's an app called IPFS Desktop. Download that. Also upload the same folder into that. Confirm the CIDs with the same. Okay. Once you have that, now you can actually, and I just want to say, now you can actually create the metadata, because notice that it's only when you have the CID, which goes right here from the images folder, that you can put that in here. Okay. So it's not like you can create the images and metadata. You need the images, then upload to IPFS through, for example, Pinata, then take the CID, and then you can create the metadata and put right here. But again, if you're doing it in a scripting language or something, like, you can just automate all that. Then after you've done that with the metadata, now you also upload the metadata to Pinata, like to IPFS. Okay, so now you have these two folders uploaded. Good. Now let's go to the Solidity contract. So this is the Solidity contract that is the NFT collection. I'm actually going to switch over to Remix, and I'll show you this. This is the exact same Solidity file over here. I have made a little change here in that I have, well, let's do it in two ways. One is that we can make the NFT collection mintable for free, or we can put a cost to it. For now, the one that's on GitHub, there's no cost to it. This one, I added the cost. So what we can do is, let's take this up for now, and then just not make this payable, so you don't have to send ETH to it. And we also are not going to check the amount, send it. So now it's free. So what I can do is take the board caps, it compiles. I'm using 0816. Notice that I inherited from the NFT ERC721. It's still OpenZeppelin. I inherit from it here. I just need to instantiate it against my parent here, which is this NFT. So I use the name and the symbol. I also store the deployer. I make an only owner modifier for the deployer. Why didn't I just inherit from ownable? Well, just because there can be a lot of bloat with that, such as renounce ownership, transfer ownership. I didn't want those things. Of course, I could override them and revert them, but I didn't want to do that. Just keep it simple. So I'm going to store deployer as immutable, so it can only be set once on construction. The base UI is the CID of the metadata folder that was uploaded to IPFS. Notice that now the image folder is irrelevant. We just want the metadata folder, because the metadata points to the image. Fine. Max supply, you can only get 10 in this NFT collection. The token supply is the NFT ID counter. So right now it starts at 0. When we mint an NFT, right after it'll tick up to 1, and so on every mint. We can view the balance of this contract. Now, since this is for free, there won't be any balance to view. It'll just stay at 0. You can change the base URI. So this is the base URI. So basically, if we want to change the metadata, we can technically do that. Re-upload to IPFS and call this change base URI. Notice only the owner, of course, can do that. All we need to do, and I'll explain now how the ERC721 puts together the link to the metadata. That's important. All you need to do is override this base URI that comes with the ERC721. It's actually in here. This is the base URI right here. Notice that by default, it returns an empty string, but we're overriding it to return the base URI. Why are we using base URI? Because at the end of the day, what really matters is the token URI. Remember that when we went over the standards? This told us, hey, by the way, the token URI right here is the function that matters. This is what should contain the metadata. So that's what we care about. So the token URI is at the end of the day what needs to return things. All right, let me go to this one. So how is that composed? Now we can override on our own, right? Notice that uses the virtual keyword. We can override this and just put whatever we want in here. But we can actually leverage this base URI to our strength and just let the ERC 721 Open Zeppelin do the heavy lifting for us. Because notice that it gets the base URI, it stores it in a string, and then it concatenates base URI with the token ID. Okay, so it just takes the token ID, say 0, and it just literally tacks it at the end of whatever this base URI returns. So it's just base URI, and then it just puts the 0 or 1 or whatever. And then that will be the token URI. So then OpenSea will go look for the image at that location, or the metadata rather at that location, which then in turn has a pointer to the image. Now, okay, now again, base URI is empty. Okay, so by default it doesn't do anything. But that's why right here, we're going to override it, you see? So we're going to override this function. We're going to concatenate on our own this IPFS. So IPFS : because we hosted on IPFS. We're going to take the base URI, which is more like a base CID if you want to be more technically accurate. We got the CID from Pinata. And then we need to just append also the slash, because again, it just takes the 0 and literally concatenates it. It doesn't put a slash for us, so we do need the slash. And that's it. That's all we need. Look at how simple this is. And even if I take out the payment part, we can just build it back in. Even if I take that out and view balance not even relevant because we can't receive any money. Look at how simple is this. This is the NFT collection. Technically, we don't even need to change the base URI either if we're very confident that this will forever be the metadata. So look at that. You know, it's pretty simple, right? You can withdraw the funds. Okay, actually, you know what? We don't even need that either. You just have this modifier only owner, which we can also argue since we removed all these other stuff you don't even need. So there you go. Maybe the deployer is not even relevant. Making it super simple here, just to show you like the very basic NFT. So look at this. We still inherit from this. We have our base URI. We override base URI with that, and we can mint. And that's it. We have a max supply. That's very, very basic. That's the NFT collection. Done. Okay, let's add in all this other stuff, and I'll explain to you why we have that. So anyway, this is to show you it's very simple, really. Cool. Now, what I want to do is, before I make this payable, meaning before we actually charge for the NFTs, I want to just deploy this. You see how it compiles at 0816. We can deploy this. I want to make sure we deploy it. We have our first address, like deploy address in these accounts we're being given just by standard in the virtual machine here. Deploy. Cool. So the address of the deployment is this. It went into this virtual environment here. It all went fine. So this is our NFT collection. Now let's mint. I can mint 1. I can mint 2. I can switch my account and mint a 3rd. Okay. Okay. What's the balance of this account? AB. It should be 1. Yes, it is because I just minted 1. What's the balance of this one? 2. Right. It's 2. Yeah. Because they minted 2. Staying on the main account, well, what is the name of my collection? Bored Cats. What's the symbol? BC. What's the supply? Is 3 because I minted 3. What's the total supply? Max supply is 10. The balance is 0. We haven't transferred any ETH to it. What's the token URI of the first token? Oh, it's this one. So this is where you can actually go and find this. If you're in a Brave browser, by the way, it understands this IPFS file system. So you can actually just copy paste this link directly and paste it in Brave, and it'll go to this image, or this metadata rather, which will then have a link to the image. Okay. Who owns ID 0? Well, that should be the main account, the one I'm on right now, actually. Yep. Who owns 1? Should be the same. Click. Yep. Who owns 2? Well, that should be that AB account. Yep. AB 8. Who owns 3? That should probably error out because I haven't minted a 4th one, which has index 3. Yep, that errored out. Invalid token ID. Okay. I can change my base URI. I'm not going to do that. That would mess things up. But I mean, I guess just to show you, I can do hello world, just a completely new thing. I changed that now. So that also means, look at the token URI now. When I click this for 0, it'll put hello world instead of the CID. Boom, you see that? Hello world. So this obviously is not going to work because there's nothing hosted there. So be careful with that. What else? I can mint. Now I did that. I can withdraw. Well, I don't have any funds to withdraw. It doesn't matter. I can do safe transfer from. So because I did inherit from the NFT, like ERC 721, I can call safe transfer from and transfer my NFT to someone else. Okay, cool. That's that really in a nutshell. That's a free NFT. Now let's put in a cost. So every time someone mints, it costs 1 Ether. I'm going to make the minting payable. I'm going to check that value that was sent, the amount of ether that was sent, is at least 1 ether. And we're just going to mint. We're not going to refund, I guess, in this case. If the user sends too much, we're not going to refund them. But what we could do is send them back if they send us too much, So yeah, we could do that. I mean, we could set a price here, right? So we can say uint, maybe public. We can do a price, and we can just say 1 ether, and we can check the price. And then what we could do is transfer back any excess. So we can actually use this syntax we have down here. This is the standard way of transferring funds. We can just transfer back basically what they sent us minus the price. Now it's probably safer to just check for the difference in what they sent and what the price is. We know it's going to be greater than or equal to, so that's fine. And then what we can do is say if this difference is greater than 0, that means we have something to send back. Like that, we can send them back this, check that it went fine, and we can send them the difference. So here we can send them difference right here. Okay. That's just a way to like refund them if they send too much ETH, and it only costs 1. Anyway, so now you can mint with 1 ether. Now the balance, we can view the balance is more relevant because that means how much have we earned from selling our NFT collection and so on. And the owner can also withdraw everything that we have received for selling this. Okay, so relatively simple. So 5B3, let's deploy it. Let's go here. I'm going to mint. Notice it's red now because it's payable. Notice that I'm not going to send any ETH right now just to see it fail. You see it fail, insufficient funds because we didn't go beyond the price. I can send 1 ether. Another way, of course, to not have to do the refund is just to require that people send exactly 1 ETH, right? That's another way to do it. So I can mint now. Boom, that went through because I sent 1 ETH. So now am I the owner of 0? Owner of 0? Yes, I am. Let me switch an account. Let me switch to this 4B. Let me try to send 2 ether. Right now I have 100 ether, so I should expect this to come down to 99, not 98. So I'm going to mint. Yeah, notice it went down to 98. Now it does the .9999 because there's a little bit of gas cost, right? That I also have to pay. So that worked fine. Let's see the balance. We have 2 ether, 1 from the first mint, 1 from the mint I just did. And notice that I only grabbed 1 ETH from this person, not 2. Okay, so that works. That's the NFT collection. That's how you can test it as well. Now, I mean, of course, in general, you'd write actual JavaScript tests and everything, right? But Remix is a nice way to just kind of rapidly develop. Cool, that's it. Now, how do we actually deploy this? So now we have the Solidity file. We have everything on IPFS. How do we actually deploy? Well, that's where, so in Hardhat, I have this config file, and notice how I do different networks like Matic, Gurley, Rinkeby, and all this stuff. So actually, yeah, this is the actual Polygon mainnet that I actually did deploy to just to try it. The process is very similar than for testnet, so nothing surprising there. I also do have the optimizer enabled to 10,000 runs. And Etherscan is used to verify, so I do need the API key here. Notice that I do use the .env package, so you need a .env file with all these keys here defined with their values. But it's just, this is a nice way to not share everything with everyone. Okay, the deployment scripts are here, or steps are here. So you can call this npx hardhat run scripts deploy, and you just specify what network you want to deploy to. So this is Polygon mainnet. It'll say broadcast is deployed, and it'll give you the address. You can verify that deployment by just plopping that address right there. It'll actually upload the source code to Polygon Scan, which is that block explorer for Polygon. And you'll have a little tick say verified. You can also deploy on Gurley and Rinkeby. And all the steps are here and everything with the contract addresses. So that's how you deploy it. Now, when you've deployed it and you actually go and mint, what will happen is you're actually seeing, you can go to testnets.opensea.io. So this supports testnets, not the mainnets. So you can actually see I minted the first one from the collection. The name is Luffe, and it's a Danish nationality. It has a blue background. It has sunglasses, yes, and so on. Notice that I tried to do some of these different attributes. It has this level with mouse kills. It's killed 10. The hunting skills are 10% because it's still young and learning, and so on. Owned by you, it says. That's great, and so on. So You can see I minted this 2 days ago, and that's it. Now, how did OpenSea know about this? Because you actually don't have to do anything. Like once you've deployed your contract and you call mint on it, and you show up on OpenSea, OpenSea is going to look for transfer events that happen during minting, and it'll look for your address and it'll display the NFT. Okay, so what do I mean? I mean, I don't have to go to OpenSea and say, oh, by the way, there's a collection at this address that I just deployed. Okay, I don't have to like manually tell OpenSea anything. It all happens automatically. Once you go deploy your contract, and you know what? Why don't we go take a look at the code? Let's say on Rinkeby. Actually, you can just go directly to this link. So you can see that it's verified. So I did call the verify. You can go interact with it on the right side of it. It has a read and write. And here you can mint. So this is what I did. I just minted from here. I had to connect to Web3. Of course, it'll connect your MetaMask, and you can click write to this mint function, and it will mint it. The point is, after you've done that, and notice nothing with OpenSea yet, after you've done that, OpenSea will automatically pick this up when you go and connect to OpenSea with the same wallet. Because OpenSea will just scan and it'll say, oh, now you connect with the wallet. I'm going to look, now I know your address. I'm going to look for all transfer events that happened, right, in the past. So this will emit a transfer event when I click the mint button. And any transfer event where your address is involved, and I'll go get all the NFT details and I'll display them for you right here. So that's pretty cool. Yeah, so that's it. So cool. That's end to end how you do an NFT collection. Yeah, DM me, message me if you have any questions or need help deploying. I am available as freelancer to help you deploy. I showed you a little bit here. We could make it more complicated as well, but I'm just showing you the basics. So yeah, thank you for watching. Take care.